Okay, this is a question about the amino acids, which are unpolite biomolecules. And then these unpolite biomolecules are compounds that have acid group and base group in one molecule. And the general formula for amino acid is this one. So in this case, the amino acid has the carboxylate group, COOH, carboxylic group, and this is also has the amine, and this is another carbon in which this carbon hold, for example, hydrogen over here, and the other one is the R group. Now the R group is basically what differs one amino acid with another. So for example, here we have alanine having RCH3, and then we have also serine, aspartic acid, and lysine. Now, among the 4 amino acids, write the structure of the amino acid that contains a non-polar R group. So basically, here we want to like compare 4 amino acids. Now, for example, if we want to draw the structure of alanine, now we will have COOH, and then we will have the carbon, we have the hydrogen, we have the amine over here, and then we also have the R group for the alanine, which is CH3. So this one here is the structure of alanine. Now, the R group over here is the methyl group, which is nonpolar, CH3. Now let's take a look at the serine. Now the serine, so if we want to draw the structure of serine, so we start with carbon, and then this carbon will attach to the carboxylic group, and then it will attach to the amine, it will have hydrogen, and then we have the R group, which is CH2OH. So this is CH2, but then we have like OH. Now here, the side group over here is actually polar because it has OH over there. So in this case, serine is polar. Now the next one is the aspartic acid. So we want to draw the aspartic acid structure. So we start with the carbon here, we have the COH over here, and then we also have the amine, we have the hydrogen, and then the R group for the aspartic acid, which is actually CH2 and then COOH. Now this one here, this is a polar group because it's actually containing carboxylic acid, so this aspartic acid is polar, having a polar R group. And then the next one here is the lysine. So if we want to draw the lysine structure over here, so we have like C, and it connects to the carboxylic acid over here, and then this connects to the amine, and this also connects to the hydrogen, and the R group for the lysine. So we have CH2, 4. So this is actually having like 4 CH2. And then this one here is attached to the amine. So this is also a polar group because there is an NH2 over there. So this lysine is polar, having polar R group. So in that case, the structure of the amino acid that contains a non-polar group is actually alanine. So here is the alanine. So this is alanine. Now the next question, write down which of the 4 amino acids above has an R group that can form hydrogen bonds with water. Having, or if we want to have, if a structure, if a chemical wants to form hydrogen bonding with water, now this chemical, especially the R group over here, because this focus on the R group, so the R group should have or should contain the H delta positive. Now this H delta positive is attached to an electronegative atom. So for example here, in the serine group, we have the R as in CH2OH. Now here, this H over here is actually the H delta positive because it is connected to the oxygen, which is electronegative. And then for the aspartic acid, for example, the H over here is the H delta positive because it is attached to the oxygen, which is electronegative. So this is also capable of forming hydrogen bonding. And then the other one over here is the hydrogen here, that is also hydrogen delta positive because it is attached to the nitrogen. So basically we have the other three, serine, aspartic acid, and lysine as three amino acids that can form hydrogen bonding with water. Okay, the question C. Some of the groups of amino acid are acidic and some are basic, and which can lead to ionization of the R group in water. And of the 4 amino acid above, write which R group is acidic and which one is basic. So we have 4, in which CH3, that's not acidic, it's also not basic. And then the other one here, serine, that is CH2OH, that is alcohol. And then the next one is the aspartic acid, that is having the carboxylic acid COOH. And then the other one is lysine, that is having the NH2 group over there. So, okay, so which R group is acidic and which one is basic? So the R group which are acidic, that is containing COOH. This is for the aspartic acid. This is acidic. And the other R group is the amine, which is the lysine. So in this case, this one, this is from the lysine. This is basic. Okay, now the next one here. If alanine, serine, and aspartic acid react to form tripeptide, alanine, serine, and aspartic acid, then draw the structure of this tripeptide. Okay, so here we have alanine. Okay, so basically, when we want to draw the structure of peptide, we actually want to draw an amide bond, CONH. So is this a reaction between carboxylic acid part of one amino acid with the amine part of the other amino acid? So now here we want to make alanine, serine, and aspartic acid. So basically we want to have this alanine, and then serine, and then aspartic acid. So we want to combine 3 amino acids. So now let's start with the alanine, something like this. So here we have H2MC. This is the R group of the alanine. This is hydrogen. And now we have the carboxylic acid which react with the amine of the serine group. So in that case, we have CO and H. Okay, and then we draw the structure of serine, which is C, and then we have like the side group of it, the R, which is actually CH2OH, and then this one is the hydrogen, and then this is actually the carboxylic acid which will react with the amine group of the aspartic acid. So in that case, this is CO and H, and then we write down the structure of the aspartic acid, which is C, hydrogen, and this one here, CH2, 4, COOH, and this one here, COOH. So this is the structure of alanine, serine, and aspartic acid. Now the next one here, the sequence of the nucleotides in the DNA forming the tripeptide alanine, serine, aspartic acid is GCAAGCGAC, and then write down the nucleotide sequence that is the complement of the nucleotide sequence. So basically we have here GCA, that is the alanine, and then AGC, that is the serine, and then the GAC, that is the aspartic acid, and then we want to write the complement. So basically we want to remember what is the base pair in the DNA, which is the ATGC, so adenine, thymine, and then guanine and cytosine. So in this case, we have like C, T, and then T, C, G, C, T, G. Okay. That is for the DNA. As for the RNA, the adenine pairs with the uracil. Now let's take a look at the next one here. So this is guanine and cytosine, and then this is the base pair, and we want to like draw the possible hydrogen bonding between cytosine and guanine, and then we want to draw the possible hydrogen bonding. Now the cytosine and the guanine has three three possible hydrogen bonding, and that is actually between this one here, over here, and then it form with this one, and then another one is like from this forming with this, and the other one is like this forming this one. So in that case, the hydrogen bonding should be something like this. So we have like hydrogen, this one the hydrogen, this one here, this is the nitrogen, this one should be the carbonyl. Now this one here, so this one should be, let's say, with the oxygen, the nitrogen, hydrogen here, another one here, this one. So here we have three hydrogen bondings between cytosine and